Alright, so this is the chemistry section 11.2 lesson video part 2. Alright, so if you made it through part 1, which was really long, I'm not going to lie, obviously I was there because I made it, then this is the second part because we have to finish that last type of reaction and then we'll kind of go back over them. So real quick, this is just a little bit of a review of how the reactions that we already talked about are kind of like relationships. So remember, synthesis is two separate coming together as one, so that's like a marriage. Decomposition is a pair that's together, splitting up, and so that's like decomposition. And you got to be careful of those diatomics on that type. Single displacement and double displacement both involve some swapping, but the difference is in single displacement, somebody is single on both sides. So there's going to be an element that's by itself on both sides. Whereas in double displacement, once they swap, everyone's still paired up. So double displacement is like Wife Swap, the TV show. I actually don't even know if that comes on anymore. That may be aging me, but so is looking at me. So anyway, let's go ahead and move on to our fifth type. So our fifth type of reaction is combustion reactions. Those are the exciting ones because if you ever see fire, explosions, things like that, that's a combustion reaction happening. So a combustion reaction occurs when a substance burns in the presence of oxygen and produces a lot of heat and light. Now, the generic reaction I gave you is a specific type of combustion reaction. Combustion occurs when anything burns in the presence of oxygen. So magnesium burning in oxygen is combustion. Aluminum burning in oxygen is combustion. But what we're going to focus on in this class is hydrocarbons burning in oxygen. Now, hydrocarbon sounds like hydrogen and carbon, and that's exactly what it is. It's a compound that contains carbon and hydrogen. Sometimes I'll give you ones that also contain oxygen too. And so when you have a hydrocarbon that burns in oxygen, so the X and Y just means these could be anything. It could be CH4, it could be C2H6, it could be C6H6, like it could just be anything. And like I said, sometimes I'll throw in an oxygen in there too, and that's fine. When a hydrocarbon burns completely in the presence of oxygen, you will always get carbon dioxide and water. Now you can have something called incomplete combustion, which you don't need to know about, and you get carbon monoxide, which you probably heard of that, carbon monoxide leaks in your house. That's where that comes from, it's incomplete combustion. But we aren't going to deal with that. We're going to do complete combustion. So when a hydrocarbon burns in oxygen, the numbers don't matter. You're going to get carbon dioxide and water every time. The hardest part about combustion is balancing sometimes, because look how big these coefficients are. There's a 25 right there, okay? So if you have trouble with those doubling, remember a lot of the balancing equations for combustion end up having that doubling thing that we've talked about. We'll go back over that, obviously. All right, so let's just go ahead and jump into some of these. So the most common mistake I see is people get combustion mixed up with single displacement because they see that oxygen is by itself. But what I need you to focus on is, remember, in our class, we're going to be doing hydrocarbons burning in oxygen. So what you need to look for is carbon, hydrogen, plus oxygen. Or, like I said, sometimes I'll put oxygen in the first compound also. All right? So to predict the products, remember, it's going to make carbon dioxide and water. So I'm just going to go ahead and put that. So the good part about combustion is there's no balancing charges, there's no polyatomic ions. Like, notice I didn't write the charges. You just got to remember, carbon dioxide, water. So the hardest part, like I said, is sometimes balancing. So we have 6 carbons right here and 1 here, so I'm going to put a 6. We have 6 hydrogens here and 2 here. So 3 times 2 gives me 6. And now I have 2 oxygens here. Well, here I have 12 oxygens, but here I have 3 oxygens for a total of 15. That's where the problem comes. So what times 2 gives me 15? And remember, you can use a calculator for these if you need one. You can always use a calculator in my class. But it's 7.5. But remember, we don't use decimals or fractions in our in our coefficients. I almost said subscripts, but then I said the right one, and then I was good. All right, so anyway, we don't use decimals or fractions in our coefficients. So how do I get rid of a 0.5? I can multiply everything by 2. So right now, this is technically a 1. You know I don't normally write the 1s, but I'll write it up there just so you can see it. So 1 times 2, of course, is 2. 7.5 times 2 is 15. 6 times 2 is 12. And 3 times 2 is 6. So that's how you do the doubling, if you forgot. If you still have no idea what I'm talking about, you need to go back to section 11.1. I think it's 11.1 that we cover balancing equations, and you need to go back and watch the doubling. Alright, so let's look at our next one. So we have a hydrocarbon plus oxygen, so I know it's going to make carbon dioxide and water. See, I like to give you the combustion ones because the products are easy for y'all to make. But you just forget about it and you try to start bonding oxygen and carbon and leaving hydrogen alone. So just remember, if you see a bunch of C's, H's, and O's, it's going to be combustion. Alright, so we have 7 carbons here and 1 here, so I need a 7. We have 16 hydrogens. So what times 2 makes 16? 8. Alright, so I have 2 oxygens. Here I have 14, and here I have 8. Alright, that's the thing you got to remember, is oxygen is in 2 places on the products. Alright, so 14 plus 8 is 22. And so what times 2 makes 22? 11. And so that's all you got to do. Okay? So you can try the bottom one. I will tell you, it's pretty difficult because you have oxygen in 2 places on the reactant side also. But feel free to try it. Alright, I'll assume you've tried it. I'll assume you got it right. And let's look at it together. So we have a bunch of C's, H's, and O's, so we know it's combustion. So we know it's going to make carbon dioxide and water. Alright, so now we got to balance this thing. So I have 6 carbons and 1 here, so I'll put 6. I have 12 hydrogens and 2 here, so I'll put 6. Now oxygen. On this side, I have 6 plus 2, which is 8. On this side, I have 6 times 2, which is 12, and I have 6 more, which is 18. Now, how in the world do I turn 8 into 18? Well, let's look at what our options are. If I try to change this oxygen, I'm going to mess up hydrogen. If I try to change this oxygen, I'm going to mess up carbon. If I try to change this oxygen, I'm going to mess up carbon and hydrogen. So I only want to put something in front of this one. Alright, so now let's look at what our options are. We need 18, right? We already have 6 right here, and I don't want to put anything in front of this because then it's going to mess up carbon and hydrogen. So we need 18, we have 6, so how many more do we need? That means we need 12. Okay, so we need 18, we already have 6, so we need 12 more. So what times 2 will make 12? 6. Alright, so see, then we have 6 and 12, which is 18. And that's it. Okay, it's just a little bit of balancing. Balancing is the best, okay? You just gotta practice it, and then you'll think it's as fun as I do. Well, I mean, I don't know that you can never think it's as fun as I do, but you know, you'll at least like it a little better. Alright, and so the important thing to keep in mind is, remember, combustion is anything burning in the presence of oxygen. I just like to focus on hydrocarbons. Okay, so if you have a different class, then, you know, just make sure that you know what your teacher expects. Alright, so let's knock out this section assessment. So what are the 5 types of chemical reactions? Alright, I'm not going to rewrite all of them, but it's synthesis, decomposition, single displacement, double displacement, and combustion. Alright, number 2, it says classify the following skeleton reactions. So in this case, I gave you the reaction. You just have to say what type it is. Alright, so let's look at part A. So we have a hydrocarbon plus oxygen making carbon dioxide and water. What does that make me think of? It makes me think of the last type that we just did. It would be combustion. Remember, combustion is anything burning in the presence of oxygen, and I will focus on the hydrocarbons. Okay, and then that way you'll get carbon dioxide and water each time. Alright, part B, I have one thing together breaking apart into 2. So one thing together breaking apart into 2 would be decomposition. Alright, here on part C, I have 2 things that are by themselves coming together as one, like a marriage. So two things come together, one like a marriage, is synthesis. So see, this is an example where technically this is also combustion, because it's lithium reacting in the presence of oxygen. But see, I don't like to give you reactions that could be considered more than one, so that's why in our class we'll focus on hydrocarbons for combustion. But just know that as you move on, combustion is literally anything burning in the presence of oxygen. So this can fall under combustion also. So just keep in mind, it's not always cut and dry one right answer. All right, and so then last one, I see something by itself, something together, something by itself, and something together. So there's some single things, so it's going to be single displacement or single replacement. I'll just write SD for single displacement. You've seen me do enough writing, right? All right, so let's move on and kind of review our reaction types real quick. So here I just gave you one of each. So let's look at all of them. So the important thing is you got to be able to tell what type it is so that you know what to do. Are you putting everything together? Are you splitting something up? Are you swapping? Is it combustion and you just need to remember carbon dioxide and water? So let's look at part A. So part A, I'm going to focus on, okay, I have two things together, calcium and iodine, two things together, mercury and nitrate. So if I have two pairs, what does that make you think of? Well, hopefully it makes you think of wife swap, which is double displacement. So I'm just going to write double displacement over here. It doesn't ask for me to say what type, but that helps you get the right answer if you know what type. So remember, for the displacement reactions, I recommend to write the charges before you even start. So calcium is positive 2, because it's in group 2. Iodine is a negative 1. Nitrate, I'm going to circle it so you remember it's all one thing, is a negative 1. I skipped mercury because it's a transition. But there's two of them. So nitrate's negative 1, but there's 2. So that's negative 2. So to cancel out negative 2, mercury has to have a positive 2. All right, so remember, in double displacement, we swap our two positives. So calcium and mercury are going to swap places. So now calcium is going to be with nitrate. I'm going to write calcium first because it's positive. So calcium's positive 2. Nitrate's negative 1. So I brought the 3 over because being nitrate means NO3. But I did not bring the 2 over because the 2 came from the fact that it was bonded with mercury. Now it's bonded with calcium. But look what it happens to get back, the 2. But I'm bringing the 2 down because I'm balancing the charges with calcium, not because I pulled it from the other side. All right, so then now mercury is going to bond with iodine. I'm going to write mercury first because it's the positive one. So mercury's positive 2, iodine's negative 1. I did not bring the 2 over because it has the 2 since it was bonded with calcium. It needed the 2 to balance charges. Now it's bonded with mercury, but look what it happens to need again, the 2. So on this one, if you accidentally brought the subscripts over for the first time, you would have accidentally gotten it right. Okay, but that doesn't happen a lot. All right, I don't even actually need to balance this one because it's already balanced if you look at it. We have 1 calcium, 2 iodines, 2 iodines, 1 mercury, 2 nitrates, and 2 nitrates. All right, so like I said, double displacement is usually the hardest for most people just because it has the most going on. Okay, so let's look at part B. We have aluminum by itself, chlorine by itself. So 2 things by itself. What's their only option? To bond together by synthesis. All right, so aluminum has a charge of +3. So I'm going to write it first. Chlorine has a charge of -1. Where did the 2 go? Well, it's not by itself anymore, so it doesn't need its diatomic 2. When it's with aluminum, it needs a 3 to balance out the charges. So then last step is to balance the whole reaction. So remember, when you have a 2 and a 3, just make both of them 6. So what times 2 gives me 6? 3. What times 3 gives me 6? 2. And then don't forget, you now have 2 aluminum, so you would go back and put a 2. All right, maybe pause the video if you haven't already and try the rest of them. So that way you can watch me do these until you're blue in the face. And we're going to keep getting them right, but it doesn't mean you can do them on your own. Okay, so maybe pause it, try it, and maybe even just try one at a time. Pause it, try this one, then watch me do it. But you've got to be able to do these on your own. All right, so part C, I have something by itself, silver, and something bonded together, H and Cl. So since something is alone or single, that makes me think single displaces. So remember, I would go ahead and start by writing my charges. Silver is a transition metal, but I gave you the hint, it's a +1 charge. Hydrogen's in group 1, so it's +1. Chlorine is in group 17, so it's a -1. All right, so silver's alone, who's it gonna bond with? Well, silver's positive, so it's going to bond with -Cl. It cannot bond with positive hydrogen. All right, so I'm gonna put Ag first because it's the positive one, Cl, negative, and so I don't need to cross anything. And then who's alone? Hydrogen. So don't forget, is hydrogen a diatomic? Yes, it is. So it's going to be H2. You got to remember those 7 diatomics. So last step is to balance. I have 2 hydrogens, so I'm going to put a 2 right here. Now I have 2 Cls, so I'm going to put a 2 right here. Now I have 2 Ags, so I'm going to put a 2 right here. All right, so hopefully you got that one right. Okay, so pause it and try the next one if you haven't already, and I'll assume we've done that. So I see some C's, H's, and some O's. A hydrocarbon burning in the presence of oxygen makes me think combustion. All right, so what does a hydrocarbon and burning in the presence of oxygen form? Carbon dioxide and water. Remember, no crossing charges, nothing like that. You just got to remember this one. Okay, so last step is to balance it. So I have 2 carbons, so I'm going to need a 2 here. I have 2 hydrogens, 2 hydrogens. I have 2 oxygens. Here I have 4. And here I have 1 for a total of 5. So what times 2 can make 5? 2.5. But we cannot have a decimal, so how do I get rid of a 0.5? Multiply everybody by 2. So 1 becomes 2, 2.5 becomes 5, 2 becomes 4, and 1 becomes 2. And then everybody's still balanced. All right, so our next one is one thing that's bonded together. We have magnesium and chloride all as one compound. So what's the only option? For it to break apart, split up as decomposition. All right, so I'm going to break them apart. So remember, I've got to keep in mind those 7 diatomics. So magnesium is not going to be alone. Is magnesium a diatomic? No. So it's just Mg. Cl is now going to be alone. Is Cl a diatomic? Yes, it is. So I'm going to keep the 2. All right, because it's going to be existing as a pair. All right, so then last step is to balance charges. Balance the whole reaction. So I have 1 magnesium, 2 chlorine, and so it is balanced. So hopefully you at least got 1 or 2 of those right. All right, I have tutorial videos on my website about this same thing, so you can see some other examples. But really, as with everything in chemistry, these just take practice. But once you get good at them, it makes it a lot better. That's why I think chemistry is so fun, is because I've had the practice, and so I'm good at it, and so it's easier for me. Okay, when you're struggling with it, it's not going to be fun, because if you can't even figure out chlorine has a -1 charge, you're going to be lost for pretty much the rest of the semester or the year. So just make sure that you take the time to practice and get good at it, because once you get good at it too, you get faster at it, which makes it not as painful to have to do these.